So welcome back to your favorite inorganic tutor YouTube channel. As usual, this is a calculus class, and I want to say a very big shout out to Mr. Rad, Enoch, and then um, Mohammed as well, and to you viewing the lesson as well. Everyone out there learning calculus. All right. So today, basically, we want to look at how we can deal with this inverse of a function. Specifically, we want to look at how we can use the inverse theorem, right? So we want to use the inverse function theory to find the derivative of the inverse of a function, right? So let's look at this function here. So the theorem actually has this formula, which is what is it? F inverse of x equals, so this is the theory we want to use, 1 over the inverse of this, right? So this is the theory we want to look at. We want to use to find the derivative of the inverse of this particular function, right? We can go the normal way, but we want to try the inverse approach, the inverse theory approach, right? So here, the first thing we have to do is that we have to find, looking at the formula, we have to find the inverse of this particular function, right? So let's go ahead. And if you have not watched the previous video, we have already dealt with how to find the inverse of a function, right? So here, we know that if you want to find the inverse of this particular function, we have f of x, which is equal to x plus 2 over x, right? Dealing with this, we know that this f of x is the same as y, right? So if this is the same as y, then the whole function is the same as all over x, right? So after doing this, you interchange the variables. X moves to y and the y moves to x. So here we have x equals y plus 2 all over y. Right. So if you have this, what you want to do is make y the subject, right? So making y the subject, we have xy, which will be equal to y plus 2, right? We just multiply through by y. And that result is going to be, right? That result is going to be xy minus y, and that should be equal to 2. So we need y. What we do, take y out, minus 1, and that should be equal to 2. So divide by x minus 1, x minus 1. So we have y equals 2 over x minus 1. Right. So this will become the inverse of this particular function. But then we want to use the inverse function theorem to find the derivative of the inverse of this particular function. So this has become the inverse of the function. As we already know, it's very simple here. We now go ahead with the formula. We have to find the inverse, no, the derivative of the function, right? So finding the derivative of the function here, we know that this, we are going to apply what we call the quotient rule, right? And the quotient rule says that we differentiate the first term, right, which is the numerator. So differentiating this, we are going to have 1, right? Differential of x is already 1, and this is 0, so we have 1, times the second term minus differential of the second term, right, which is 1, times the first term. all over the square of the second term. Right. So if you have this, we can simplify to this. X minus into bracket x plus 2 all over x squared. Right. Now, let's come up here. Let's maintain the formula so that we can look through and be making our analysis. Right. So let's simplify this. When you simplify this, the derivative of the function now becomes x minus 2 all over x squared. And this gives us, this takes off this, and we have minus 2 all over s squared. Right. So we are following the principle or the theorem, right? Now we have the inverse of the function and we have the derivative of the function. So what we do is that we substitute the inverse of the function into the derivative. Right. So here, let's maintain the formula and clean this part. So here, let's deal with the denominator first. So the derivative into the first derivative, the inverse of the function, should be equal to, now we are putting the derivative into the inverse. Where is it? Here, right? So we're going to have minus 2, let's cross check, minus 2 over 2, no, we have minus 2 over s squared all squared because of this all squared here, right? So we can go ahead and say minus 2 over 4 over x power. Is that true? Let's go back here. Yeah, it's x minus 1 rather. So minus 2 over 2 over x minus 1 all squared, right? So because of this here. So let's simplify this here. 2 over 4 all over x minus 1 all squared, right? And up here there is a minus here. So we have right? So here we are going to have minus 2 divided by 4 over x minus 1 all squared, right? So if this is our normal operations, then we're going to have minus 2 times x minus 1 all squared over 4, right? So this is basically going to be minus 2 into x minus 1 all squared over 4, right? And this is minus half into x minus 1 all squared, right? So this has become the denominator, right? So now we can fix this denominator, take it 1 over this function that we have gotten, and then we can have the derivative of the inverse of that particular function we wrote earlier on. So here we can say that is equal to 1 over this, which is minus half x minus 1 all squared, right? So this, we can simplify it further, and we can say that this is equal to minus 2, this will go up, so we say minus 2 into x minus 2 over x minus 1 all squared. Right, so this is our final answer to the function that we were given to find the inverse of it, right, which is s plus 2 over x. Now, let's try something here. Let's try something here. We could remember that we had the inverse of the function as 2 over x minus 1, right? So this, if we are to take the derivative of this inverse, we are supposed to land on this same solution, right? So let's try it and see. But the idea is that we want to use the inverse function theorem, right? So if you have this and you want to confirm whether your solution is right or not, just use the inverse. After finding the inverse of the function, find the derivative of it. If your answer is the same as using the theorem, it means you've confirmed your solution, right? So here, you can see that this, we are going to apply the quotient rule. So we differentiate this and it's go to 0 times this minus, we differentiate this, which becomes what? 1. 1, right? Times the first term, which is 2, all over the denominator squared, right? And this will basically be 0, which is, we all know is 0, and this becomes minus 2 all over x minus 1 all squared. So if you use the theorem, have your final answer, and you are not sure, and you have to confirm, right? And you can conclude on your solution. So just make sure that your derivative or the inverse of the function that you found, make sure that it's right. And then you take the derivative of the inverse. If the derivative of the inverse is right, then your theorem that you use must also be right, right? So it's the same idea, but you want to use the theorem function formula, right? So let's take our next problem and see how we can go about it. Well, we'll go. Uh, let's look at another problem on the same inverse theorem function, right? So our next problem is f of x is equal to the fifth root of x, right? So this, we already know that this is equal to y, right? So if this is equal to y, then we can see that this, and we know that this is x power 1 over 5, right? So if we are to find the inverse of this, we already know that when we interchange the position of the x and y, it's going to be the same, right? But what we have to do, we do interchange the position. Let's interchange the position here, and we have y power 1 over 5, right? And we need y. So what we do, we multiply both sides by what? Take the exponent of 5, and this takes off this, and we have y equals x power 5, right? So this becomes the inverse of the function, which is x power 5, right? So when you have the inverse of the function, then maintain it, find the derivative of the actual function or the original function given. So when you find the derivative of this function, which is y equals x power 1 over 5, the derivative of this, right, is going to be 1 over 5 x power minus 4 over 5, right? So we have this, so just apply the theorem, which is f, what is it, f inverse of what, the derivative of the function. Hope you are right. All right, so we have right, good. So just want to put the inverse into the derivative. So here let's confirm what we're doing. So when we substitute that, we are going to have 1 over 5, right? And then the x here is what? Y power 5. X power 5, right? So we have x power 5, 4 power 1 power 5, 4 over 5. That is minus, right? So we have derivative of x, and that should be equal to 1 over 5, which will be x power minus 20 over what? 5. And that simplifies to 1 over 5 x power minus what? 4. And this becomes the denominator. So now we can say that the theorem now concludes to be is it f of x inverse or derivative. That is the theorem. So now we take 1 over this denominator, which is 1 over this x power minus 4, right? So this now becomes 5 over x power minus 4 as our final answer. So now what we have to do is that this is what, 5 x power minus 4, right? And this is the same as 5 x power 4, right? And this, we already know that we can confirm this by going ahead to find what? The derivative of the inverse. Where is the inverse that we found? X power 5, right? The inverse was x power 5. So if we want to confirm this, then we find the derivative of this, and that will be equal to 5x power minus 4, right? You know, we bring the 5 power 4, sorry. So we bring the 5 here, and then we take 1 from this, and that is equal to this. And that is perfectly what we have here, which confirms our theorem, right? So let's check on the next problem. Very quick one. G of x is equal to 1 over x plus 2, right? So let's erase these parts first, right? So that's all right. So this will be our third problem. All right, so g of x of this function, and this is the theorem. We already know the theorem we are applying, and we know that this is basically equals to y, right? So if this is equal to y, then we can interchange the position of the variables, and that will be x equals 1 over 1 y plus 2, right? So if you need y to be the inverse of the function, what you do is that you multiply through by y plus 2, right? So spread the x and you have xy plus 2x, and that should be equal to 1, right? So if you need y, send this here, maintain this here. So you have xy should be equal to 1 minus 2x, right? So if this is true, then we can divide by x here, and then we can have the y to be equal to 1 minus 2x all over x. And this becomes the inverse of g, right? So if this is going to work using the formula, then we have to find the derivative of the function, right? So the derivative of the function is going to be, let's apply the quotient rule here. So applying the quotient rule, we know that this is going to be 0 times the second function minus the differential of the second function times the first function. So we have 1 into 1, and that is all over the square of the second function, right? So this, basically, we're going to have j, derivative of j equals minus 1 over x plus 2 all squared. Right. So now we have the derivative of the function and we have the inverse of the function. So now we can put the inverse of the function into this. Right. So we're going to have g, the derivative of g into this here. And then we are going to put this into this. Right. So we're going to have minus 1 all over x. Where is the x? Now the x here, we are going to put all of this. So we have 1 minus 2x all over x, right? Plus, plus 2 all squared, right? So we're going to simplify the denominator so that our work will be much easier, right? So here, simplifying the denominator, let's forget about the minus 1 now, minus 2x all over x plus 2, right? We know this is over 1, right? So basically this is x here, and then we have 1 minus 2x, right, plus 2x. So this is what the denominator is going to be, 1 minus 2x. Basically this will go off, right? So we have 1 over x all squared, right? So if this is true, then we can take negative 1 of this, right? So we have, let me clean this and remain the formula there for you. Remain the formula. Okay, let me clean everything. So now we have this here. So negative 1. So this is basically equals 1 over s squared, right? So negative 1 all over 1 over s squared, right? So with this, we can say that minus 1 times s squared. So let's use the dots here, over 1. So we have negative s squared as the denominator, right? So now, as we have the denominator, so now we are going to use the theorem which says that 1 over the denominator of this, right? So 1 over this, then we're going to have 1 over negative s squared, right? And that's it for this question. Okay, so now we know that we can testify whether what we have is right or not. So we can use the inverse solution that we have, find the derivative of it. If the result gives us this, then means our answer is left, right? So now let's find the derivative of this, right? And see. So the derivative of this, we are going to have minus 2, right? Minus 2 times the x, right? Minus this, which is 1, minus 2x, right? All over s squared, right? And this we have minus 2x minus 1 plus 2x, right? And this is s squared. Are we going to get the same thing? Yes. So basically we have proven that our answer is right. So the theory doesn't lie. So we have minus 1 over s squared. And that's great. Great. So you can pause the video as you watch and then basically give a try on this basic things as well. I think we worked about 3 questions, and then let me give 2 more questions for you as a try. I'll provide the final answer, of course, so that you can give a try by yourself. So let me give this 4th one to you. Find the derivative of the function, of the inverse of this function, using the inverse function theorem, right? And then the 5th one, the fifth one is f of x equals 1 minus 2x all over, let me give you this basic one. And this, our answer is going to be 1 over 3, then the cube root of s squared here. So this, the answer to this particular question is this, right? So you can go through the process. This is basically the same as 1 over 3 x power minus 2 over 3, right? We know that when you take this is the same as x power 2 over 3, and since it is 1 over, it's going to be negative. So that is basically what we have here as this. So this question is for you. You can give it a try. And then this f of x equals 1 minus 2x. This is very easy for you to do. So this, I will not provide the answer. I know this is very easy for you. So thank you very much for watching, everyone out there. Please, the next content is going to be how we can find the derivative of a particular function when we are given the function in the natural log form. All right, so bye.